Okay, today's lesson is over percent error, which the official definition is how far off the accepted value your data is. Basically, this is a measure of how wrong you were or how bad your results are, if you want to put it like that. It really doesn't measure how good or bad you did your experiment. It just measures how good or bad your results are compared to what they should have been. And it's used as a guide to see whether or not something is wrong with your experimental setup. Okay, so it doesn't always have to be negligence on the part of the scientist, but it could show the scientist that maybe there's something wrong with the equipment's faulty in some way, or maybe there's bias somewhere in the equipment that needs to be addressed. Alright, so let's go ahead and work through the formula real quick, and then we'll do an example. So percent error is the theoretical value. Theoretical just means the accepted value we talked about earlier. For example, we had talked about the density of water having an accepted value of 1.00 grams per milliliter. That is the accepted or theoretical value that all of the scientific community agrees upon. Alright, then we have the experimental value. That's what you would get when you run your experiment. So whatever you got in the lab is your experimental value. Okay, so let's look at the previous example from the earlier video where we ran an experiment on the density of water. Okay, so here we have Mike and Allison and their data again. So we have two sets of data. Now, looking up at the formula here, we have a spot for the theoretical value and we have a spot for the experimental value. Okay, we do not have a spot for three separate trials worth of data. So there are two approaches to this. You could find the percent error for each trial individually, or you could find the percent error for the entire experiment by taking the average of all of the trials. And I think that that's the method that we'll go with. Okay, so let's tackle Mike's data first. So you'll see down here that I have averaged Mike's density data. So this is the average density of water that Mike came up with. And so we'll use that in our percent error formula. Alright, so we've plugged in the information into the percent error formula. You've got the theoretical value, which is 1 gram per milliliter. We've got our experimental value, which is the average density that we get from Mike's data, all divided by the theoretical or accepted value down here on the bottom again. You'll also notice that this formula is in between absolute value bars. So it is impossible to get a negative percent error. And the reason for that is because nobody's perfect. We don't live in a perfect world, so you will never have 0% error, and obviously you can't have less than 0% error. You will always have some kind of error in your experiment. So when we crunch the numbers, we get 0.33 repeating percent error. So that's a really good result there. That means we were not that wrong, or at least Mike was pretty good in his experiment. Doesn't seem to be much wrong with his equipment, and he must have been very dutiful during the experiment itself. Alright, now let's look at Allison's data. Okay, so I've taken Allison's results and gotten her average density up here at the top, and that's what we have placed into the percent error formula as the experimental value, and we have 1 gram per milliliter again as the theoretical or accepted value. So when we crunch the numbers on this one, we get 41% error. Okay, and the 41% here is only two significant digits because we had 0.68 up here, and that only had two significant digits in it. Actually, coming back up here to Mike's data, there should be one more 3 in here because all of our initial data points had 3 significant digits for Mike's data. So you'll notice, obviously, that Allison's results are quite a bit, or her percent error is quite a bit higher than Mike's is. And obviously, like we said at the beginning, the reason for that could be many things. It doesn't mean that Allison did a bad job necessarily. It just means that there might be some problems with her experimental setup, and she'll need to go in and take a look at that and then redo her experiment so that she can bring her percent error back down to a reasonable level, because 41% is not reasonable. Alright, so that's really all I have to say about percent error formula. Take a look at your notes packet and do some practice problems, and I'll see you next time. Thank you.